At this point, we can make a summary of what we know about feedback so far. One, we know that our feedback is named based on what we do at the input and what we do at the output, and it dictates what type of input or output connection we have. So let's look at several cases here. So at the input, we can have either a series connection or a shunt connection, and at the output, we can do the same, series connection or a shunt connection. All right. If we have a series connection at the input, this is going to increase the impedance, and we would like to use this for a voltage at the input. Shunt connections, we do the opposite. We would use a current at the input. At the output, series connections we use to increase the impedance, and so we would like to use these for current outputs, and shunt connections we would use for voltage outputs. So our types of amplifiers are series. This means that we would output a current, input a voltage. So we would have a trans resistance amplifier, a transconductance amplifier. We have series shunt. Output a voltage, input a voltage. This is our basic voltage amplifier. We can do shunt series. So we're outputting a current and inputting a current. So this would be our current amp. And finally, we have our shunt amplifier. Here we're going to output a voltage and input a current, or this would be a trans resistance amplifier. Now remember, shunt connections reduce impedance by 1 over 1 plus the loop gain of our circuit, and series connections increase impedance by 1 plus the loop gain. All right, we can make a few further notes about the types of parameters that we use to solve these circuits. So we've already seen a few of these amplifiers. For our transconductance amplifier, for instance, we use Z parameters in our feedback network. For voltage amplifiers, we used H parameters. For current amplifiers, we will use G parameters. And for trans resistance amplifiers, we will use Y parameters. And we'll learn to use those in the next part of the lecture.